I'm going to do a little bit on PowerPoint slides. We're going to do Smartboard here first. Matter is the stuff that makes up our universe. I mean, there's only two topics that we've truly covered in chemistry: energy and matter. Matter can be divided into two sections. One is called a pure substance, and the other is called a mixture. Now, a pure substance is the same throughout. If you look at a sample of it, it's all the same no matter where you look. We've actually covered pure substances first semester. We just never referred to them as that. There's two types of pure substances. There's elements. It's carbon throughout. And there's compounds. So it's H2O. It's H2O throughout. It's C6H14. It's NaCl. It's the same throughout. So first semester, the first unit was just introductory chem. Hey, let's learn what significant digits are. You all love that now, don't you? No. Let's learn how to read things correctly, you know, all that stuff. Second unit was on the atom. That's when we talked about individual elements. Third unit was on compounds. So we talked about those two different types of pure substances. Now we can get into these different types of mixtures instead. Mixtures can be divided further. Some mixtures look the same throughout. Those are called homogeneous. A solution, which is mainly what we're going to be talking about in this unit, is a type of homogeneous mixture. A solution is when you combine two or more things together, and it evenly distributes throughout, although I'll give you the definition of a solution in a little bit. In parentheses, I have a specific type of solution called a tincture mentioned. It's something that we used to cover more in years past that we're probably not covering much now. A second type of homogeneous mixture we actually talked about a little bit at the end of last semester. When we talked about metallic bonding, we talked a little bit about what an alloy was. It's a mixture of one or two or more metals. Some people, if they get dental work, a filling could be an amalgam. It's a specific type of alloy. Some things are not able to mix evenly. And hopefully, you will be able to identify why some things can mix and some things can't. Hopefully that's been an emphasis today. Things that aren't able to mix evenly are called heterogeneous. Again, hetero, different. I'm giving 3 examples of heterogeneous mixtures. A colloid is kind of an unusual one. A colloid is when you have, let's say, a liquid phase, and then you have solid phase floating within it. But it's not evenly mixed, it's not able to dissolve. You can tell the parts. You can have pepperoni pizza as a heterogeneous mixture. You can tell the different parts. A homogeneous mixture is the same throughout. A suspension isn't just what Mr. Borowski comes in here to hand out to you guys every now and then. In a chemistry term, a suspension is when you try to mix two things together and they can't. So they settle to the bottom over time. An example I'd give for that is I have an aunt and uncle who rent a cabin up in Door County every year. So their cabin is right on the beach. Before you walk into the cabin, there's a big pail of water that you're supposed to put your feet in to get the sand off. Sand being a solid, water being a liquid. What happens is the sand doesn't mix with the water. It settles to the bottom. That's what a suspension is. An emulsion is when two liquids are unable to mix. Beginning in class, we talked about how oil and water can't mix. So you'd have two different liquid layers then. Quite frankly, these terms on this page are not ones that we're going to test you on. We're not going to test you on what an emulsion is versus a suspension. However, you should know what a solution is. So here is the textbook definition of a solution. A mixture of two or more substances uniformly dispersed throughout a single phase. Here's the problem when students blindly look at a textbook and write down a definition. They don't stop and think about what does this actually mean. A mixture, okay, I know what a mixture is. Two or more substances, I know how to count. I know 2 or more things. Uniformly dispersed. Well, that means it's spread out evenly. Throughout a single phase, in a solutions case, it's all liquid. There are no layers. There are no parts. Quite frankly, that rubbing alcohol that you used in the marker demonstration isn't pure rubbing alcohol. There's a little bit of water in it. It's a solution. You can't tell the rubbing alcohol part from the water part because it's uniformly dispersed. It's spread out evenly. Again, in years past, this was its own unit. We called it the solutions unit. Going over how things are able to mix and hold together is our goal. So this is one term that we should know. We should know what a solution is. My last slide of notes is going to go over other terms that we have to be aware of. Again, we are not a vocabulary intense course, like say a biology class is at times. However, some terminology is so commonly used when describing certain chemical processes that we all have to be on the same page with some of the words that we use. So first off, solvent is one that you saw. Solvent is the thing that does the dissolving. Far and away, water is the most common solvent. But you could have nonpolar things that dissolve. We will show you that next class period. Solute is the thing being dissolved. Now again, I'm using my general way of explaining this. You could look in the textbook or online to see specific examples. Salt is a good example of a solute. The ocean is a solution. It's a saltwater solution. Water is dissolving the salt. Solvent, water. Solute, salt. You definitely want to know those 2 terms. The last 2 terms to wrap up notes today. Miscible, which is just a fancy way of saying it's able to be mixed, and immiscible. 2 things can't mix. The goal of today was to show you why some things can mix and some things can't mix. But we also have to have you aware of the vocabulary used to describe that. As you're finishing up this slide of notes, I'm going to hand out the homework, which the homework is drawing out dissolving. So, drawing out when some things can mix and when some things can't mix. Remember that idea of like dissolves like. Things with charges mix with other things with charges. Things without charges can only mix with other things without charges.